Thank you for joining me on this exercise 3G. I'm going to be looking specifically at question 1B. Question 1B states, given the complex number Z1 is 1 plus I, Z2, the second complex number, is 3 minus 2I, and Z3 is negative 2 plus 3I, calculate Z1 over Z3 minus Z2 over 5. All right, so let's substitute. Z1 is 1 plus I. Z3 is negative 2 plus 3I. Z2 is 3 minus 2I over 5. Now, we've got this divided by a complex number. What we're going to do is take that fraction 1 plus I over negative 2 plus 3I, and we're going to multiply top and bottom by the conjugate of the denominator. Now, the denominator is negative 2 plus 3I, so we're going to make it negative 2 minus 3I, and we put that both on the numerator and the denominator. Notice what I've done. I've taken this and I've multiplied it by the conjugate. So instead of negative 2 plus 3I, it's negative 2 minus 3I. I'm just going to leave this second fraction alone for a moment. Let's expand that, and we've got negative 2 we've got a negative 3I or negative 3, sorry, let me just go back. We've got 1 times negative 3I, yeah, that's correct, is negative 3I. Now the next one is I times negative 2. So that's negative 2I. And the last one is I times negative 3I. So I'm just going to put negative 3I squared. All right, let's do the denominator. Negative 2 times negative 2 is 4. Negative 2 times negative 3I is positive 6I. 3I times negative 2 is negative 6I. And 3I times negative 3I is negative 9I squared. All right, so that's that fraction. Let's just leave the second one alone for now. Let's simplify this. Now we've got this one here, negative 3I squared. Now negative 3, we know that I squared is negative 1. That's an important skill in complex number. So negative 3I squared is negative 3 times negative 1, which becomes positive 3. So I'm just going to change that line to being negative 2, negative 3I, negative 2I, and I'm changing that to positive 3. Okay, let's look at the denominator. And the same thing here, negative 9I squared is negative 9 times negative 1. So that's going to be positive 9. So let's just do that. 4 plus 6I minus 6I and plus 9. All right, leave the second fraction alone for now. I'll just put that in here. Now let's take the real components. We've got negative 2 and 3, so that makes 1. And we've got a imaginary components, negative 3I and negative 2I, so that's negative 5I. and the denominator, 6i, negative 6i cancel. That will happen when you multiply by conjugates. And we've got 4 plus 9, and that makes 13. Now notice what we've got is two fractions, no complex numbers. They're both real components. So I'm going to take this 5 and multiply it up here, and we're going to take that 13 and multiply it up here. So we're going to cross multiply 5 times that. Then we're going to have minus 13 times that. That's the denominator from the other fraction. And then all over. And we're going to have our denominator as being 13 times 5. And so we'll fill this in. 1 minus 5i, 3 minus 2i. Okay, we'll get common denominators of 65. Here we go. 65. So 5 times 1 is 5, minus 25i, minus 39. That's a negative times a negative, so it's plus 26i. And let's just get our real components, and we've got negative 34. Our imaginary components, we've got plus I over 65. And there we have it. I hope this has helped. Let's just, until next time, stay happy.